Okay, ready? Okay, you guys? I can't remember, you guys, the last time I saw an AP exam that didn't have a differential equation as a free response. And it's easy. I'm going to go through this slowly. If you get the steps down, even if you have a tough time with algebra, you can get most of the points. And if you don't get the steps down, you won't get the points. It'll be 5 points, and it's easy to get 4 out of 5. And it's easy to lose 4 out of 5 if you don't do the first step. So, first let's go back. What does it mean to solve an equation? Oh, Casey's been listening. That's right. Find a number that makes the equation true. That's important to remember when we are doing these differential equations, because you are going to have functions and they're going to go through a particular point. And you have to decide which function, given that ordered pair, will be true. You'll see. It'll happen to us. Okay. What is a differential equation? Remember, this is a test question. Okay, Max? Okay, a differential equation is an equation. This is a test question. It's worth 2 points. It's an equation which involves derivatives and when you solve it, what are you solving for? Not a number. It's a function whose solution is a function. And today we will do the differential equations and we'll point them so you can see how easy it is to get 4. The 5th point is tough. Just gonna say that. Okay, so let's do a word problem. Now this word problem that's here is like a multiple choice question. It would not be free response. Free response, they set you up for success. They give you enough information that you should be able to do something. Sometimes they mess up. Yes, it was 2007 question 3, and the average was 1 point out of 9. The average. It was so hard for the kids. No, they do adjust. They do kind of curve the exam. However, in 2010, they didn't like the results and they didn't curve the exam. They did not curve the exam any more than they normally do. So there were fewer passing grades that year. Well, they would like it, but they will not lower their standard to get that. Yes. Okay. Only 25% of the AB students got a 3 or better, I believe, on the exam. Not here. Yes. I get a lot of papers that I read that there's nothing, that teachers don't teach everything that needs to be taught. You are getting everything that needs to be taught. But we're much higher than that. I can bring the stats in for you so you can look at it. No. No, because there are people who don't do any work. We're way above the national average. Probably even the state average. But how do we do it? You do the work and you come to the study sessions. You don't have to come. We do study sessions at night for about 3 weeks before the exam. And that's when we just do problem after problem after problem. And you'll see that when I give you the differential equations for the last 2 years, okay, you guys? The differential equation for the last 2 years, Jack? Declan? It's the same question, but in a different context. One's a waste problem, one's a bird problem. When I read the bird problem and I finally saw it, I go, it's exactly the same. And it was almost exactly the same as the year before, which is really rare. They usually like to change it up. But honestly, it was almost the same exact question. And we will do those. The AP people, usually college professors. Okay? No. It's tough security. The test is written 2 years in advance. Well, they test it. They want to make sure those questions are good questions. They obviously failed in 2007 on one of them. Okay, so let's do this problem. Okay, guys? Put your history book away or whatever it is. Okay, consider the function whose slope is always the square of the x-coordinate. Okay, guys? You're not going to know how to do this. So I want a function whose slope is always the square of the x-coordinate. We've translated word problems into math problems. How do you write slope? You're in calculus class. What's slope? F prime of x. What's that other name for it? dy dx, right? Okay, remember, a differential equation involves derivatives. So I'm going to use dy dx, and we're going to get all the steps here. I'm going to write them out for you. So dy dx is equal to, and it says the square of the x-coordinate. So what's this equal to? Square of the x-coordinate. So what is it? It's too easy. X squared. If you think some things are easy, they probably are. Okay, so here are the steps for solving a Diffie-Q. Now, generally speaking, on the FRQs, they're going to give you the equation. It won't be as easy as this one. But first thing you do is you separate the variables. If you don't separate the variables, you are eligible for no more points. Those are easy to grade. And this one's an easy one to separate. So I'm going to cross multiply. Separate. That's so good. So dy is equal to x squared dx. Okay, I got my point. First point, separated the variables. Now, what I mean by separating the variables, okay, Samuel, is that you have only x's on one side and only y's on the other. You can't have x's and y's on the same side. So I've seen a lot of students come in and try to integrate ones with x's and y's on the same side. Those are easy to grade. They get nothing. This is not what I want to see. I want to see 9s. Okay, so it's easy to separate. Well, sometimes it's not easy to separate. You'll see some today. Then what we're going to do is we're going to integrate both sides. Okay, guys? We're going to integrate both sides. So that is 1 point. Sometimes it's 2. If the integrals are tough, then they might give you 1 for each one. But, you know, these aren't that tough. So I want to anti-differentiate this side and anti-differentiate that side. There's a function in there. It's 1. What's the antiderivative of 1 with respect to y? That's y. Remember when we started doing that a long time ago and now a struggle? You're getting it now. Okay? What's the antiderivative of x squared? X cubed over 3. That's okay. Good attempt. You wouldn't get the point. But as long as you don't make it a whole lot simpler, you're still eligible for the next point. No, if you miss this, you can still get the point. Now, we've got one more point here. And if you don't do the next step, you're not going to get that point. Plus C. Plus C. If you put it in later, you're not getting the points. So, add C. Okay, trying to emphasize this. Do you remember that now? So I can slide this. No, it's fine. I should slide it. There it is. X cubed plus C. That's my magic pen. Okay. So we've got 3 points out of 5, and honestly, it wasn't that tough to separate. These antiderivatives weren't too bad. Sometimes they can be hard. and it wasn't hard to put C in, and then you put in the ordered pair. You go for the particular solution next. And that, you have to put them in the right place. But if you don't have to evaluate it correctly, that's for the final point. What ordered pair did it go through? 1 and 4/3. Okay, so what goes in for Y? So this is 4/3. That's it. Yes, but you do have to put them in the right place. You can't switch X and Y. Now, if you switch X and Y, you don't get this point, but you might get the answer point if your rest of your work is correct. Usually that's the hard part, though. So what's C equal to? 4/3 minus 1/3 is 3/3 or 1. Okay? So you're going to substitute in the ordered pair, substitute the initial conditions. So it's not really that hard to get 4 points out of 5. And then you answer the question. Find the function. You must find y equals. Okay, so what's y equal to here? It's equal to x cubed over 3 plus 1. Now, how do I know I did it right? It said, find a function whose derivative is x squared. What's the derivative of this? What's dy dx? What happens with the 3's? They cancel. And that's what I wanted. I'm taking the derivative of this. And the derivative of 1 is 0. Okay? Sometimes it's 6 points. If the integrals are hard, then it's going to be 1 point for each integral. Yes. Okay, guys? Adding C is the third point, and I want to be kind of consistent here. And substituting in so that you could find C is the fourth point. The fifth point is finding C and solving for Y. This is the work one. And when you're on the exam, and you guys aren't listening, when you're on the exam and you are looking at your clock and you've got everything down to the first 4, and you really know how to do this other problem, skip it, come back to it if you have time. No, don't waste your time with that. You only do the creative picture after you know you're done. Check over your work. Now, the exam has 2 parts to it. You have the calculator and the non-calculator for the FRQs. Okay, guys? Stephen? So you get, Declan, you get 30 minutes for the 2 with the calculator. Then you put your calculator away. And then you get an hour for the other 4. But if you finish the other 4, you can still go back to the calculator part, but you can't get your calculator back out. You can go back. And usually it's not that much that's going to be requiring a calculator. Maybe it's an integral. Maybe it's just a numerical derivative. So do that stuff first. Put them in the right places. Sometimes they do, sometimes they don't. But because sometimes they might ask you for an average rate of change and then an average value. These are last year's BC's exam, but I have the AV ones too. And you can see that the questions are typed in there. Now, this one's nice. I can read it. I don't know. One of our students, I don't know. Because we do not write in the book at all. We just use scratch paper and bubble things in. So, but I wanted to look at these to see what my students missed. Okay, you guys. Hey, you guys, you're having too much fun. No fun in math class. Okay, let's do another problem. Turn the page. Okay. There it is. You guys need to know that definition, a differential equation. It's on the test, worth 2 points. We should have everybody get it right. It's an equation which involves derivatives and whose solution is a function. Now, I'm not going to follow the directions here, okay, Casey? It says find the general solution. I'll find the general solution if I have to. Okay, guys, I'm getting you ready for the exam. Jacqueline, you need to listen. And I'm not going to do that. I'm going to find the particular solution. It's easier to do that than it is to find the general solution and then substitute in. I see many students find the general solution and substitute in, but it's a lot more difficult. And if you don't try to substitute in, you're not going to get as many points. So you want to get as many points as you can. So here's my differential equation, and what's the first thing we do? Look at the other side of your notes. What do we do first? Separate the variables. How are we going to do that? We need to do this with me. This one's multiply by dx. How about just cross multiplying?
Do it.
Then I get y times dy equals x times dx. If you try to integrate it as written, you will get nothing. You have to separate the variables. Okay, girls? Do you have that? I want all the y's on one side and all the x's on the other. You cannot undo adding. It's a lot of algebra here. Here's the calculus. We integrate both sides. Now, we've got 1 point because we separated. Hopefully, we're going to get another because we integrated it correctly. Grace, what happens to that? Y squared over 2. Now, that's going to be a problem, but you'll see what happens with that problem. So this is going to be what? X squared over 2. Okay, I did that right. I got another point. And then what's next? No. Let's see. Well, if you're good at that part, you can do this. You got 3 points out of 5. We haven't hardly done anything. Now, the rest is algebra. And we're going to substitute in the first point. We'll talk about the second point in a moment. So it's 2, 4. So where do you put what do you put in for y? 4. Okay, Declan, you should be working this with me. So you should. No, we're going to do the first one first. We could do the second one first, but it's 4. You'll see what happens. It's 4 squared over 2 equals, guys, you should be writing this down, 2 squared over 2. You should be ahead of me, plus c. I could. That's a good question. I could have a c here and a c there, but I'm going to put all my constants together and put them on the other side. I don't know what they are separately, but I do know what they add up to. It doesn't matter. It's arbitrary. Okay, what's this answer? 4 squared over 2. 8. 16 halves is 8. And this is 4 halves, so it's 2 plus c. What's c equal to? Okay. Now, I tried to put the numbers in. I did do it correctly, but I got my 4th point. Even if I put them in the wrong place, I don't get that point. But if I mess up with the c, that's okay. I just won't get the answer point. That's all. The answer point is a hard point to get. Okay, so I've got y squared over 2 equals x squared over 2 plus 6. And why is it hard? Because I have to solve for y. That's not done. Not divide by 2. Multiply by 2. Yes, but we have a little issue when we square root, which I'm not sure if you know that. But so y squared is equal to x squared plus 12. Okay? Jack, what do I do next? Square root. Can I square root these individually? I have 3 squared plus 4 squared, and I square root that. That would give me 3 plus 4. But really, this is the square root of what? 3 squared is 9 plus 4 squared. That's 25. Is that a true statement? So may you distribute a square root over a sum? No. You can't ever distribute a square root over a sum. You can't make it x plus the square root of 12. I will read no further. Okay, so here's the hard part. What am I going to get when I square root y squared? Do I get y? Now, I don't get plus or minus either. I get the absolute value of y. Noah remembers. This is equal to, and when you square root, you always get a positive square root. So when I solve this equation, we're trying to find numbers that make the sentence true. There are two things I can put in here that make this sentence true. I could say that whatever goes in there for y is the square root of x squared plus 12. Or whatever I put in there, y could be the negative of that. Because isn't the absolute value of the negative of this also positive? Yes. Okay. So now you're on the exam, and you have two solutions. There's only one because we're looking for a function, and it goes through the ordered pair 2, 4. And all you do is put it into both of those, unless you're thinking a little bit more, and see which one makes it true, because only one's going to make it true. First one or second one? First one. That goes into this one. What about this other ordered pair? We had 2, -4. If I put that in the first equation, it doesn't work. Does it? Because this is not plus or minus, it's the absolute value of y. So this ordered pair, this equation right here, makes this one true. If I include both, I don't have a function. It's not a function. Because you got the upper branch, you got the lower branch. I don't even know what it looks like. That is not a function. This is not a function. Does not pass the vertical line test. Oh, no. They're both functions. You can't give me the answer y equals plus or minus. You have to decide which one is it. Is it the positive one or is it the negative one? Sometimes it's the negative one. Yes, for 2, -4 is. This graph is the positive one. This is the upper branch, that's the lower branch. If you think of it geometrically. Yes, I've seen it happen on the exam. I've seen some teachers say, the absolute value is not important. It's critical. Well, I tried to explain that, but anyway. They're still teaching it wrong, as far as I know. Okay, so let's try another one. There is no particular solution, so we're going to have to go for the general solution. Well, 2, 4 goes in this one. Whoops, sorry, goes in this one. And 2, -4 goes in that one. Two different answers depending on which point we're going through. There aren't any points in example 2. And if you look at example 2, it looks kind of hard. Does it look hard? We can do it. I like that. We can try at least. Okay. It's the cube root of x squared times y. We need to separate that. So the first thing is, I don't like the radical. So why don't we make that a fractional exponent? So dy dx is equal to x squared times y to the 1/3 power. Can I distribute that exponent across multiplication? Not addition, but multiplication. Yes, you can. So you want to separate those x's and y's. And right now, they're connected because they're in that parentheses, and I don't want that. Pardon? No. Not if it's addition. So this is equal to x to the, now you multiply these, remember that? To the 2/3 times y to the 1/3. Now I'm ready to separate these. So let's multiply through by what? Dx. Get rid of the derivative first place. Right? Okay, so I get dy, and some people will get this far on the exam, and then they just won't go any further, and they get no points. Nothing, yes, we haven't separated. If you don't separate, you can't solve it. This is a technique. There's a whole course in this. Can't integrate. Why? I got this guy right there. You have to separate. You cannot have x's and y's on the same side. So we will, that's right. You're going to take relief, take full relief. You cannot have x's and y's together. So what are we going to do? Divide by what? Y to the 1/3. Just take it slow like this. Check when you're working your differential equation, say, are the x's and y's mingling together? No. This is y to the 1/3 equals x to the 2/3 dx. Oh, that looks better. Because we don't know multivariable calculus. We don't know how to integrate an x and a y mixed up with a differential dx. I don't know what to do. Okay. So we're going to integrate this. Okay, Declan, what am I going to do with that one? The y's. They look like a problem. Now, it's the power rule. The power rule applies to any exponent, if it's a power, except for 1 over x, x to the negative 1. But this is okay. This is y to the negative 1/3 dy. We always put them up in the numerator, but if that exponent is negative 1, then it turns out to be a log. X to the 2/3 dx. And what is the antiderivative of y to the negative 1/3? You're going to go up 1. What's 1 plus the negative 1/3, Jack? You should be doing this with me. We're adding 1. 3/3 gives me 2/3. Did I do that right? And again, this negative 1/3 with 3/3. And then you're going to add 1 to 2/3. Oh, wait, I forgot something. Divided by 2/3 is the same as multiplying by 3/2 equals, then this is x to the what? We're going to go up 1. Well, 5/3, but you see how easy it is to do that. And then this, let's get 3/5. Now, if you make a mistake on that, you don't get the point for that, but we're going to get a point for our c. Now, if you do the problem and you add the c at the very end, forget it. You're not going to get the points. The c is too late. Okay? So if the c's, if you try to do this, solve for y, and then add c at the very end, the c is too late. It's got to be right here. It's got to be now. Okay? Is everybody clear on that? The c has to happen now. Okay. It was so quiet yesterday. Okay. Here's the hard part. We have to solve for y. They didn't give me a particular solution. If they did, Declan, we would put the point in there, we'd find c, and then we'd solve for y. Well, I don't know what it is. So we have to solve for y here. So I don't want the fraction, so what could I multiply to get rid of? Well, 2 doesn't go into 5. How about 10? Now, some of you guys can think of reciprocals. If you see it another way, that's great. I'm just going to do it this way because we don't care if we reduce or not. That's not important. Okay? So I'm going to get what? What's the coefficient going to be? 15. Y to the 2/3 equals 6. X to the 5/3 plus 10c. Okay, now I don't want what? I don't mind the 10c. Remember, I want to solve for y, so I want to get rid of 15. Now, I don't care if I reduce this or not, so I'm not. Because if I do it wrong, it's wrong. Okay, girls, do you have a question? David. Yes, provided I know what I'm doing. In fact, you can call it a different constant. It doesn't matter. You're going to have a particular solution there. I'm just trying to be consistent. So I'm going to get, so we're not going so low on the board, y to the 2/3. I'm not going to simplify that. It's equal to 6/15 x to the 5/3 plus 10/15 c. And since this would be like an FRQ. Still not. This is all for 1 point.
Yeah, why would you do this?
It's for 1 point. Because if you have time, I would do it. You want to get the point, but not many people do. Because I'm telling you how it's scored. It's always scored the same.
Like, how would you just how are you going to be able to be like, oh, that's the 1 point problem?
No, it's 5 points here. You got 1 point. Here you got 1 point for separating. I'm telling you, it's always graded this way. Always. Every single differential equation is graded this way. 1 point for separating, 1 point for integrating, 1 point for C. So we got 3 right there. Then by putting the number in, which we don't have, you would get another point. And then the last point for solving. So I want to solve this. So how do I solve this? Raise this to the y. By the way, this is all algebra. Now, some of you want to do this individually. You can't. Never operate on a side individually. It's always the side is raised to the power. And that's done except there's one little detail here. Well, it's a very subtle detail. No, you can't distribute. Not allowed to distribute exponents over addition. Well, it's done, but when I take the square root, first I cube both sides, and then I get y squared, just like we did before. And when I take the square root, I get how many answers? 2. I get the positive root, and I get the negative one. Remember? From the preceding problem. So because I don't know what c is, there's a plus or minus here. They won't ever give you to you without giving you a particular solution. They'll give you an ordered pair it goes through. So once you do that, you can decide if it's a plus or the minus. Yes, it's possible that they'll give you one that's negative and you won't bother to check for the negative answer. We will do lots of problems that come right off the exam. I promise. Okay, let's try another one. Ready? This is a good one. This is a little easier. That last one was kind of tough. This last example, I'll leave it for you to try. You cannot do that one. It's plus. The only ones you can undo are multiply and dividing. Okay, so how are you going to write that, Declan? Well, how are you going to do that? Okay. No, they're still connected. So can you distribute exponents over division? Yes. So this is x to the 1/2, and this is y to the 1/2. We're going to cross multiply. So when I multiply these together, I'm going to get y to the 1/2 equals, whoops, forgot to do y. And then you do a quick check. Do I have all the y's on the left and all the x's on the right? That's right. And if you don't separate, you try to integrate right here, you get nothing. We don't even look at it. That's wrong. Do you see why it's still positive 1/2? Okay. Because this is, you're just going to multiply these. This times this, and dx times x to the 1/2. Okay, so we got 1 point, and now what are we going to do? Integrate. And because I write so big, we'll go up here. What's the antiderivative of y to the 1/2? It's y to the what? F times what? 2/3. By the way, when you do this, if there's a number over here, like 2 or something, always leave your constants with your x values. It's going to be easier for you to work. Okay, so then this is what? It's x to the 3/2 times 2/3. It's the same integral, right? Plus c. Okay, so we have the antiderivative, we have the separating, which is right here, and we have the c. We are at 3 points. Now we're going to get our 4th point, so we're going to put in 0, 9. So where does 9 go? Good. Because it does matter. They get particular about that. With the particular solution. You can just leave it. We are going to simplify because we can. That's right. Well, this is 0, right? Now, how do you do 9 to the 3/2? You do the square root first, 3, and then 3 cubed is 27. So c equals 18. Okay, now I have to put that into my equation. I've now got 4 points out of 5. Can I get the 5th point? Okay, so I'm going to recopy this down here. I don't have any room. I wrote really big. Pretty much. It will be somewhere, but it usually has been a free response. I want to solve for y now. So what can I do to solve for y? Multiply by what? 3 halves. Now, do I have to simplify the 3 halves over here? No. I mean, I will. So y to the 3 halves. What happens to those? Grace, what happens to those? X to the 3 halves. And I'm too lazy. Oh, no, let's do it. But normally you could leave it. What's half of 18? 9 times 3 is 27. And now what are we going to do to both sides? Raise it to what power?
Wait, so it's like half of 18. Yeah. No, 30. Divide 18 by 2 and multiply by 3.
You could go 3 times 18, which is 54, and divide it in half. It's 27. But your arithmetic skills probably aren't as good as mine because I didn't have a calculator. Okay, that's the answer. Do I need a plus minus with this? No, why not? Because it's a what root? It's a cube root. The odd roots are going to be whatever you get. The even roots are always going to give you a plus minus. Should make sense. No, it's a cube root, and that thing is squared. It's squared, not a square root. We found C. There it is. Okay. I did right up here.
27.
It ends up being 27. Okay, page 357. We're not doing this. It doesn't hurt you to do the quick review, but I know you don't do it. Anyway, so it's 1 through 9. I don't even think you do this. How many problems is 1 through 9 odd? 5 problems, okay? That's not too bad. Plus you have a take-home quiz, which I'm going to give to you right now. It's due tomorrow. Where are you going to be? Oh, nice. Are you in it? Well, you're going to go watch it. Cool. Take-home test due Thursday. Okay. What time is it? Oh, I said it was 6 problems. Sorry. No, it's 6 on one side and it's 4 on the other. Okay, so first, before I do that, let's do questions on the pink one. Front side. Now, if you haven't done it, it's hard to ask me questions. Jacob has an excuse not to have done it. So, Declan, where's yours? Yes. Number 10. 10 is a good one. Thought I gave you one, but okay. Okay, you guys, it's a time test. I can play Mozart, but you know how long it's going to take me? And it's not going to sound very good if I don't practice. Those people who play, they practice. Those people who play sports practice. Okay, so it's a time test. You don't have extra time. You can't be sitting there trying to figure it all out in your 4.5 hours. Plus, you're going to get tired. Okay, so number 10. And we have enough time to do a bunch of problems, actually. Now, behind me, I wrote this problem a little differently. I'm going to write it differently here. Okay, Declan, get your pink worksheet out. So it's the integral of the log of x times 1 over x dx. Now, if you still have questions on this, you come in tomorrow morning and ask me questions on this. We'll not answer questions on the quiz, but I will answer questions on this. Okay? Do you see that those are the same things?
Yes.
And they told you to use substitution. U is equal to the log of x. And if you don't, we're not going to tell you on the exam. You're going to have to figure it out. Same as the ones that's on my shirt. You have to figure out what the U is. I'm looking for a function, and I'm looking for its derivative. Guess what? There's the derivative. And the only way you start to recognize these faster is to do them, because there's only so many you can do. So what's du? What's the derivative of the log? 1 over x dx. Yes, you have to always have a differential. So this is going to be du, and this is going to be du. So it's going to be the integral of u du. Oh, that's pretty easy. Okay, what's the antiderivative of that? U squared over 2 plus c. Don't forget to find the antiderivative. Some of you kind of forget to do that. And then put u back in, which is the log of x. Ln of x. And you can always check. Because we have to do a substitution to make it an easier problem. Oh, this one's tough. Well, that's on my shirt. Are there other ones on the front side? Yeah. 7. I think I remember that one from today, too. Okay, you guys, number 7. Okay. And they are so nice. So if you do the front side, that helps you. But then the back side, you're on your own. Oh, I copied that wrong. Makes a big difference, too. It's the secant of x squared. It's not secant squared of x. And they tell me that u is equal to x squared. Then what's du? 2x and times what? If you don't put the differential in there, then all bets are off because you got to keep track of everything. And the problem is if you are lazy with the differential, how do you know what you're keeping track of? You don't. So this together with this is equal to du. You see that? I could move them together. And then this part here is going to be u, and that's u. So I'm going to be left here. The integral of secant of u, tangent of u, du. Now you have to know your antiderivatives on that white sheet. What is it? What is the antiderivative of secant tangent? You have your white sheet? It's on there. Remember, everything has to look like what's on the white sheet. If you can't do it, you can't do it. It's the secant of u plus c. Okay, Jack, what's the derivative of secant? Jack, it's secant tangent. So we're not done. We got to put the u back in, which is x squared. But you created it to look like that, which you may think is not that easy, and it's not. But it was certainly easier looking than the original one. You're trying to make them all look like what's on that sheet. And no, you're not allowed that sheet on your quiz. Well, you will be on your quiz, but on your test. Yeah, I can't monitor that. Are there other ones you want to look at on the front side? Number 11 is a tough one. Now, they didn't give you the u substitution. Now, why is this one tough? Is that a 3 or a 1? It's a 1. You know what? In this case, it is going to matter. But, okay. Whoa, that's the question. What's u? There are 2 answers for this. 5x cubed. So if u equals 5x cubed, and the only way to know is to try it. So du equals what? 15x squared dx. So let's try that. I have a 15x squared dx. That would give me my du, and this is going to give me my u. So I'm going to get the integral of 3 to the, I want this to be 5x cubed plus 1, don't I? I think so, because what's the derivative of 5x cubed plus 1? Because otherwise I was going to have to do u plus 1, and I can. It's just harder. It's easier to do this. And then this is du. Do you remember the integral of a to the x? So that's what this is. Remember that the derivative of a to the x, and you made me prove it yesterday, if you remember. No, is a to the x times the natural log of a. That's my name. Almost. So what if you integrate it? You're going to get 3 to the u, but not times the log of 3. If the derivative gives you times log of 3, then the integral will be divided by the log of 3. And so it's 3 to the u, which is 5x cubed plus 1, divided by the natural log of 3 plus c. And I know if it's right or wrong. How do I know? Take the derivative. So let's do that. The derivative here is equal to, I'm going to be doing a lot of these today. Okay, so first I'm going to ignore the 1 over the log of 3 because that's a constant. So it's times the derivative of this, which is 3 to the 5x cubed plus 1, times the derivative of that, which is 15x squared, times the natural log of the base. Why did I have to divide by the log of 3? To get rid of this. Mm-hmm.
So it works.
Mm-hmm. Does work. Now, sometimes you can't do a problem. I never know. What do you think the u is going to be on 12? I'm looking for a function, and I see its derivative there, or a multiple of its derivative.
3x squared plus 8.
That's right. And there are some tough ones. There's whole books of integrals.